concentration. Sometimes you'll see people stated as H3O plus. It basically is just meaning that it's the hydrogen's easy to fall off on the H3O plus molecule, which is basically representing acid, and it's going to go inside of the solution. So it's just a representation of the H plus items. So in this case here, 1.0 times 10 to the negative 5 is the concentration. When you take the negative log of it, it's 1.0 times 10 to the negative 5. And then when you do the negative log, you'll get 5.0. And important part, when you're doing your calculations on the calculator, be very careful, because when you're doing the calculations, do not hit the minus button that's over by the times, divide, multiply, because that is different than the little minus sign that's on the bottom near the zero key. So you want to use the one near the zero key. It has the little quotation, or not the quotation, but the parentheses around it. So please use that one. Otherwise, it will probably not give you the right answer. Most of the calculators I've used, it will give you an error or not work at all. Okay. Another example, how about 1.0 times 10 to the negative 3? So we're going to do the same thing again. I noticed I did a little mistake there. I said H, it should be pH there. So it's negative log 1.0 times 10 to the negative 3, or it gives you a 3.0. Very strong. And like I said before, it dissolves your enamel on your teeth. That's why soda is bad. And if you do drink soda, they usually recommend drinking water with it afterwards. Okay, another one. You'll hear about pOH. Now, pH and pOH are actually two separate things, but they're very similar to each other. One is a measurement of hydrogen ions. The other one is a measure of hydroxide ions. So in this case here, it's the opposite, and you calculate the exact same way, but a little bit different, whereas where the pH, where anything less than 7 was acidic. In this case, the pOH, anything less than 7 is a base. pOH of 7.0 is a neutral. And then in this case here, a pOH greater than 7 is actually what we call acidic. So it's kind of reversed from our pH, where the pH, anything that was lower than 7 was acidic. Anything greater than 7 was considered basic. But like I said, you kind of calculate the exact same way. Instead of using the concentration of the hydrogen ions, you use the concentration of the hydroxide ions. So do pay attention for this, because that's going to be on the lab today that we're going to be doing. Once again, how can we distinguish between the two? Well, very interesting relationship between the two. The pH plus the pOH equals a total of 14. Remember, the scale was 0 to 14. So in this case here, we have basically pH plus pOH equals 14. Makes it simple. So in this case here, we got an example where pOH is 5. You want to know what the pH is? Well, it's pH plus 5 equals 14. Or in this case here, subtract 5 from both sides, and you end up with pH equals 9. So it's actually a base. And you go, wait, that pOH, it says 5. Well, if it was a pH of 5, that would be an acid, but in this case, it's a pOH of 5. And remember, that's opposite, which means anything less than 7 for pOH is actually a base. So in this example, we switch it to pH, and we got a pH of 9, which is a base. So remember that little trick there. Can I go in reverse? Let's say they don't give you the concentration, but they give you the pH. Can you still figure out the concentration? Yes. Once again, use the exact same formula. It's going to be pH equals negative log of the concentration of hydrogen ions. If you're doing it for OH, you'll substitute the pOH equals negative log of OH. This case here, I got a pH of 3. So I got 3 equals negative log of H plus. Basically, raise the log to the power of 10 in this case. And you lose the log, and you get 10 to the negative 3 equals H plus. And then that gives you 0.0010 equals the concentration of H. And to put in a formula, or basically a format you recognize, the hydrogen is going to equals 1.0 times 10 to the negative 3 for the concentration. So remember that. We're going to be doing that. Here's a good little resource for you guys to use. This is found on KC through 12. Very good. It gives you kind of like how to convert between OH, pOH, pH to pOH, pH to H, or H to OH. So very interesting. Do use that if you need that. And our laboratory today. So real quick, going over this laboratory, we're going to be using the FET lab. It's going to be doing the pH, and we're going to be calculating the concentration, and we're going to be calculating the pH based upon the concentration. So part A on your lab paperwork today, what you're going to do is be taking the pH of several different solutions. In this case here, it's water. You're going to go to the macro, and that's going to be the first one you use. You're going to have a little container that's going to be filled up with the liquid. The little tiny green thing, that's your sensor. And what you're going to do is move that sensor over to the container, and it's going to give you the pH. So in this case here, water, as we discussed before, it's neutral. It's a pH of 7.0. So when we switch it, you're going to go up to that little top there where the little down arrow is with the dropper. You click on that, you can switch between the different substances. So in this case here, we're going to add battery acid. And you notice my little tester is there, and it says it's a pH of 0. So you're going to go through multiple ones. I want you to measure the water, the battery acid, the coffee, orange juice, milk, soda pop, human blood, and drain cleaner. The good thing about simulations like this is you don't have to worry about cleanup. And if you mess up anything, it's quick to go back and check again. So make sure you guys get all those and answer the questions. Now I'm going to go to the next part here. This is both part B and D. This is going to require some calculations. You're going to have to be calculating the pH, and you're going to have to be calculating the pOH. So if you forgot, go back to the slides, check it. I also got the resources on your lab handout, so you can use those too. So you're welcome to use those. If you need help, I'm available to help after class too. All right, this time you're going to go from the macro and you're going to switch to the micro lab. And in this case here, it's going to give you concentration, a little bit different. And you're going to notice when you put the solution in, the pH meter is a little tiny, looks like a flag there, but it says pH, and it's going to give you what the pH is. In this case here, I got drain cleaner in the example, and you're going to notice there's a concentration of H3O plus and OH minus. Now, those are your concentration of hydrogen ions versus your hydroxide. So if it's a base, your OH should be greater than the H plus. All right. Example, battery acid. So this one here, do the samples like I told you before, get them in there, record the concentration on the table, both the H3O plus and the OH minus, okay? And once again, that's over there where it says concentration moles per liter. That's the molarity. And do it for all of them. And when you start doing the dilution for this one, you got to be very careful. So you'll notice on this slide here, it's 1/2. I want you to cut the concentration by 1/2 each time, and I want you to note the pH and mark the pH down and the concentration. So you're going to use that little tab there where it says water. Very carefully tap it, and you're going to bring it up to 1 liter. Try to get as close to 1 liter as possible. You may not be able to get it perfect, but it's not going to make a big difference. So if you end up with like 1.05 liters, that's okay, or 0.98 liter, you're close enough. So what you're going to do is dilute it by basically 50%. Check the pH, write that down, check down the concentration H3O plus and the OH minus, okay? And then you're going to basically empty it out to 1/2 liter again, or basically halfway, and you're going to fill it back up with water. So you're going to do that multiple times until you basically get a nice little readout of basically changing pH and changing concentrations. You're going to analyze that later. It's going to be part of your homework. And so you're going to go all the way down to basically 0.8. I want you to record the pH of that one. And you're going to do the concentration on part D too. So don't forget that one. Then I want you to graph it. This graph is pretty close to what yours is going to look at. I want you to basically extrapolate it to where it would technically be neutral pH. See what you guys get. Okay, so give it a little bit extra there for the pH. You know, pH may end somewhere. We're trying to shoot for neutral. We'll see how close we get to neutral doing these ones, okay? And I won't tell you too much there. We'll explore your graphs when you guys come back tomorrow. Answer the discussion questions. So like I said, I want to know what happens if you extrapolate it all the way to 0, and what would happen, and basically what happens when you dilute the solution to the point where you can't dilute it anymore. I won't basically ruin the surprise, but we'll see what you guys come up with, okay? And then, like I said, part D, you're going to write down the pH, the concentrations. pOH, oops, sorry, pOH doesn't seem to be on the chart. What are you going to have to do? Oh, you're going to have to calculate it. How are you going to calculate it? Refer back to the slides. If you need help on calculating those again, I can help you with that. So you actually have to calculate pOH for that one. All right, next one, the very last part. You're going to notice it says concentration, but you're not going to copy the pH from the actual lab note. So you're only going to put the concentration down, and then you're going to calculate the actual pH based upon the concentration. You're going to do that not for the pH only, but you're also going to do it for the pOH. So I want you to do at the end, calculate the pH and the pOH, and then I want you to compare the two to the other one that you did back here where you actually wrote them all in, okay? Because that's going to be one of the discussion questions here. I want to see what you guys can discover from that, okay? And once again, that's pretty much it. If you need any help or any resources on that, I'm here to help you. And good luck, and I'll see you guys tomorrow.